Analysis. Hi, good morning, everyone. Sorry, guys, I'm a bit busy with college work. So, do you know that mid-exam was conducted for final year?
Good morning, sir.
Good morning, good morning. Do you know?
Sir, వాయిస్ కొంచెం స్లో వస్తుంది సార్.
మీ అందరికి తెలుసా మిడ్ ఎగ్జామ్స్ కండక్ట్ చేశారు ఫైనల్ ఇయర్ కానీ? ఏం మిత్రులు?
Sir.
Is it audible, guys?
Yes, sir. No.
Yeah,
Yes,
yeah.
sir.
So,
Audible.
know that final year students exam conduct చేశారు తెలుసా మిడ్ ఎగ్జామ్స్?
తెలుసు సార్.
So even for you also there will be mid, okay? So don't forget your third year subjects. So please try to revise the content which we discussed in the design of shear stresses. What is the strength today, Mithun?
సార్ లాస్ట్ క్లాస్ కి 18 మెంబర్స్ వచ్చారు సార్.
Okay. Right. Okay, so let me share the screen. So today we are going to discuss about prestressed concrete structures analysis towards shear. Okay. Good morning all of you. So I think in the previous class we have done with the quiz. So few attempted, I mean, very well. And rest of they have to practice. Okay. So I request, I already forwarded you the notes, right? So please guys go through the notes and please be up to date with the prestressed structures. So whenever college starts, so definitely we'll start with a good industrial visit where I will try to show you how the pre-tensioning and post-tensioning of structural elements like sleepers, precasting elements, girders, so these all we can see it in Hyderabad itself because there is a lot of construction is going on. Even post-tensioning slabs are also going on. Okay, so they are very nearby, so we can go and visit them, right? So then you will have a clear idea on it. Okay, so I think in the previous class we discussed about analysis of prestressed concrete structures towards shear, right? So let me just revise the content. So this is the analysis of shear. Sorry. Analysis of shear. So here shear analysis is taking place with the three different mechanisms. One is equilibrium, the other one is compatibility, and the third one is consecutive relationships of different materials. Okay, out of in which I think conventional analysis for shear is only based on the equilibrium of forces. So with the simple equilibrium conditions. Okay, based on that only the prestressed concrete element will be analyzed in terms of shear. Okay, so here whatever the shear stresses which are going to be generated in beams due to bending, or twisting. So because I think you all done a lot of experiments in strength of materials on it. When the member is subjected to torsion, you are going to calculate the shear modulus or modulus of rigidity, so which is talking about the shear happening in the member. Okay, So the two types of shear stresses which are we called as a flexural shear stress and torsional shear stress. Okay, so this is what we are going to calculate. Okay, in in analyzing the member towards the shear, right? So the stresses in uncracked beam. So we already seen that. So here the when a beam is subjected to uniformly distributed load, you can find the shear force diagram and bending moment diagram where the variation of beam will be the normal variation like this, and the shear stress variation will be like this. I think this also we gone through. This is the variation of forces and stresses in a simply supported beam, right? And the next one is calculation of shear demand. So where exactly the shear demand will be takes place. So the shear demand will be takes place at the circumference of the section, right? If you take a rectangular beam, at rectangular beam, you are supposed to provide the shear reinforcement only on its circumference. Okay. So the main objective here is to provide the ultimate resistance for shear, which should be greater than the shear demand under ultimate loads. Okay, so obviously your design shear should always be greater than the applied shear force, right? So that is how the calculation of shear demand will take place. So let us take for continuous prestressed beams. So there will be a rigorous analysis will be done based on the moment distribution method. Okay. So else the shear coefficient which was given in IS 436-2000 in table number 13. So which is based on the different conditions of uniform cross section of the beams and uniform loads and even the based on its length. I mean length nothing but length of the spans. Okay. So this is which is talking about the shear demand. And the next one is design of stirrups. So this also we gone through. So where exactly you will provide stirrups in a beam. So at the mid span of the beam, the spacing of the stirrups will be more. Why? Because the shear stresses or shear force will be less. Okay. So shear force will be maximum towards support. By that, more number of stirrups will be provided with less spacing towards the support. Support in the sense, so one fourth of the distance at supports will be having more stirrups, which takes care of the shear forces. And its center, there will be maximum bending moment. Shear stresses will be very less. Okay, at center it will be almost zero for a simply supported beam. So in that way, the stirrups are going to be provided. If you take a cantilever beam, exactly at cantilever beam, the bending moment and shear force will be more at support. So by that, the spacing of the stirrups will be very less towards the support. Okay. And towards the free end, the spacing of the stirrups can be more. Okay. So in that way, the stirrups are going to be designed. Okay. So for designing the stirrups, same as per 456-2000 only, we will go through the design concepts. Okay. So the next one is the design of transverse reinforcement. See, what is the difference between stirrups and the transverse reinforcement? So transverse reinforcements are nothing but a reinforcement which is going to provided to take care of the shear force. Okay, so that is the meaning why it was mentioned that the transverse reinforcement. What do you mean? What are the two reinforcements will be there in a beam? There will be a longitudinal reinforcement, which is also called as a within its length. And the next one is lateral reinforcement, which is also nothing but transverse reinforcement, which is provided on its circumference, right? So when the shear demand exceeds the shear capacity of concrete, so obviously the transverse reinforcement will be in the form of a stirrup. Okay. So ఎప్పుడైతే exceed అవుతుందో, we are supposed to be provided stirrups along its circumference, right? So the stirrups going to resist the diagonal cracks exactly, and it's gonna have check a diagonal tension failure and shear tension failure also. Okay. So in that way, the stirrups are going to resist a failure due to shear by several ways. How better the transverse reinforcement is going to take care different types of failures. So let us go with the different types of functions over here. The functions of stirrups are going to be listed over here. The first one, stirrups resist a part of the applied shear. Exactly. So the stirrup reinforcement is only to take care of the shear forces, isn't it? So the one reason why you provide a transverse reinforcements, nothing but stirrups resist part of the applied shear. Second one, it will resist the growth of diagonal cracks. Okay, so I think you all know in your RCC, the shear cracks will be at an angle of 45 degrees at the ends, right? So why? Because there will be a maximum shear force towards the support. So by that, it will resist the diagonal cracks. Okay, so stirrups are provided to resist applied shear, and the next one is to resist the growth of the diagonal cracks. And third one, the stirrups counteract widening of diagonal cracks, not only controlling the cracks, even if the crack exists, it will counteract and it will control the widening of the diagonal cracks. So which will maintaining aggregate interlock to a certain extent. Okay. So providing the transverse reinforcements, I mean providing stirrups in a beam, okay, leads to counteract or controlling the widening of the diagonal cracks. Okay. So which is going to be maintain aggregate interlock to a certain extent. Okay, aggregate interlock చేస్తుంది అన్నమాట ఆ stirrup reinforcement. And the next one, splitting of concrete cover is restrained by the stirrups by reducing dowel forces in the longitudinal bars. Okay, so that is also one of the important uh, you know um, function of a stirrups which are going to be provided in the field, right? So concrete cover towards the main reinforcement fit అవ్వకుండా కూడా the stirrups are going to be provided. Why? Because if you see the main reinforcement which was provided in the beam, so there will be just over the cover block. Kada? Just imagine there is no stirrups. So how you are going to provide the main reinforcement? The main reinforcement will be placed on the cover block, okay, below the neutral axis. Kada? And on top also there will be a reinforcement. Without stirrup, how your main reinforcement will be, will be located at the same place. ఎలా మీరు రిజిడ్ చేయగలుగుతారు reinforcement? You can't. So you have to tie with a certain reinforcement to make it at a certain position. ఆ పొజిషన్ ఉంచడానికి you need a certain reinforcement. So in that way also your stirrup is going to be useful, okay, in restraining the stirrups by reducing the dowel forces in the longitudinal bar. ఈ longitudinal bars ని exact location లో ప్లేస్ చేయడానికి మీకు ఎక్స్ట్రా reinforcement కావాలి. If there is no stirrups, ఆ ఎక్స్ట్రా reinforcement అవాయిడ్ చేసి just by having a stirrups you can make your reinforcement at the same location. ఆ లొకేషన్ లో ఉంచేటట్టు చేస్తుంది అన్నమాట. Okay. So in that way, so there is a 4 different functions of stirrups. ఎవరైనా మిమ్మల్ని అడిగినప్పుడు, okay, even in interviews also they're going to ask you, what is the main purpose of stirrup? What is the main purpose of the transverse reinforcement? You have to tell that. First one, it should taking care of shear forces, and the next one to restrict the diagonal cracks, and third one, not only restricting, even to avoid the widening of the diagonal cracks, and to maintain aggregate interlocking, okay, at a certain extent. And the fourth one is to avoid the dowel reinforcement bars, okay, to locate the main reinforcement in the same location. Okay, ఆ location లోనే ఉంచేటట్టు ఆ stirrups అనేవి మనకు ఉపయోగపడతాయి. Understand? In that way, shear reinforcement is going to be useful in any kind of longitudinal member. Understand? Right. And so these are the functions అన్నమాట. ఈ functions చాలా చాలా important. So please try to go through all this. Right? Very important. In the next one, after cracking, so what happens? The beam is viewed as a plain trussed view, right? And the top chord and the diagonals are made of concrete struts, exactly. And the bottom chord, okay. So if you take a beam, so which is viewing as a plain trussed మీరు ఊహించుకుంటే, the top chord and the diagonals are made of concrete struts, and the bottom chord and the verticals are made up of steel reinforcement type, isn't it? So based on this truss analogy, so what happens? The ultimate limit state and the total area of the legs of the stirrups is going to be given formula like this. I think you all know this formula, so which is there in your IS 456 2000 also. Area of shear reinforcement by shear force is equal to, right? So here you can see the notations. SP is nothing but spacing of the stirrups. DT is nothing but greater of DP or DS, right? And the DP is nothing but depth of center of gravity of steel from the extreme compression fiber. DS is nothing but depth of center of the non-prestressed steel. What do you mean non-prestressed steel? whatever the reinforcement which we provided in a prestressed concrete beam, okay, to have a skin reinforcement. A shape తీసుకురావడానికి, right, to make that into an I shape or a rectangular shape, whatever the reinforcement we provide, right? So that reinforcement is nothing but non-prestressed steel element. ఎందుకు what మనం stressing చేయం. That steel is only to take care of the shear and only to take care to make that into an I shape. Okay, దాన్ని మనం skin reinforcement అంటాం, right? So let us see the notations over here. Then we can discuss about the formula. So SV is spacing of the stirrups. dt is nothing but greater of dt or ds. Okay, the dt value which you are going to consider, which is the maximum of these two. What is this? Depth of center of gravity of steel from the extreme compression fiber, depth of centroid of non-prestressed steel. So we have to take the greater value of these two as dt. And the next one is Fy, which we all know is the yield strength of the stirrups. Okay. So the grade of steel for stirrups should be restricted to Fu456 or lower. Okay. You should not go more than Fu456 because you will have an Fu550 steel ఉంటుంది, you know. So you should not go more grade steel for stirrups. Okay. So why? Because no need of that. You can go with even Fu250 also for making a stirrups. And the diameter of the stirrups also, it won't go beyond the 16 mm. Understand? So it will be like 8 mm, 12 mm. Okay. I mean 8 mm, 10 mm, 12 mm or 16 mm. That's it. They won't go beyond 16 mm even to make a stirrup reinforcement. Okay. So this formula will shows you to calculate the total area of the legs of the stirrups. Okay. With this present formula. Okay. And VC is nothing but shear force in concrete, and this is nothing but ultimate shear force. Okay. And the next one is design of stirrups for flanges. How you are going to design stirrups for flanges? So because in your bridges, particularly your prestressed beams will be in the form of a I shape or T shape long. So there will be flanges. And how you are going to provide stirrups for flanges? Flanges ఎలా provide చేస్తాం? If it is a beam, so there will be top reinforcement, bottom reinforcement, and there will be stirrup, isn't it? But coming to an I beam, so there will be two flanges, top and bottom, and there will be a web, right? And how you are going to provide stirrups for flanges? Flanges ఎలా provide? For flange sections, although the web carries the vertical shear stress. I think we all know, even in your steel structures, I told you, if you take an I section, top flange will take care of the compression forces, bottom flange will take care of the tensile forces, and the web will be take care of the shear. Okay, అది మనకు తెలుసు కదా. So in the same way, for flanged sections, particularly like an I section, T section, angular section, C section, okay, so the web carries the vertical shear, no doubt at all. But there is a shear stress in the flanges due to the effect of shear lag. That is very, very, very important. Okay, please highlight this. Okay, because we all know web carries the shear stress. Okay, web carries the shear forces, and by that we have to design web under to have a maximum shear stress. Kada? But why we have to design flanges also for shear? Why? Because there is a possibility of shear lag. Shear lag effect అనేది మనకి వెబ్ ఫిల్లింగ్ చేసుకుంటాయి. Okay, shear lag effect అంటే there will be possibility of you know transverse force takes place in the flanges. Flanges లో ఆ transverse force జరుగుతుంది అన్నమాట. Effect of shear lag ఉంటుంది. So horizontal reinforcement in the form of a single leg or closed stirrups is provided in the flanges. మీరు I sections లో top లో మీరు చూస్తే there will be reinforcement which will be in the form of an I shape. Okay, not only the main reinforcement, there will be a reinforcement which will be in the form of an I shape లో మీకు ప్రొవైడ్ అయి ఉంటుంది. Okay, that I will show to practical way. Okay, so that is how or else let me show you pictures right here. One second. Shear stress. Let me show you that picture by way of able to understand. So this is the best example. So where we can do the 1 second. Auto reinforcement. 1 second. Let me get that thing. One second. No? So let me show you. I'll try to show you. Uh, Rotate it. So this is one of the major bridge. So this is the concrete bridge and material. Okay. So bridge having 4 PSC girders. Okay. So now you can see. Okay. So this is RCC girder. So bridge for span having around 4 PSC girders and matter. Okay. So the girder is in I shape. So you can see. Girder A shape lo undi, I shape lo undi. Okay. So this is an I shape of a PSC girder. Okay. So let me show you the reinforcement details of an I girder. So by that you can easily identify and recognize the reinforcement. Okay. So this is an I-shaped girder. Okay. So what is the reinforcement over here? So these are the main reinforcement, bottom, right? And top reinforcement. So these are the top reinforcement. Okay. Here we showed it to top reinforcement. So it was given as 4. This observe change. 4 Y12 anundi. What do you mean 4? 4 into 4 bars. 1, 2, 3, 4. Please follow my cursor. 1, 2, 3, 4. Y12 and the diameter of each rod is 12. Okay. And if you observe carefully, there will be a reinforcement. Okay, so which is the shear reinforcement, even in the plane. ఇప్పుడు ఈ ఐ సెక్షన్ కి ఫ్లేంజెస్ ఏం చెప్పండి. The top is an I shape. Okay, bottom is also an I shape. I mean flange kada. Top flange, bottom flange, and web. So if you take this as an example, so here let's show what is the main reinforcement and stirrup, shear reinforcement. Okay. There is no mark kada. Okay. No issue. ఇక్కడ చూడమ్మా, bottom. What is the diameter of these rods? Y12 mm dia, two rods here. Okay, and if you can see the vertical stirrup చూడండి, ఒక పెద్ద stirrup ఉందా. So this is a stirrup. So this vertical stirrup is provided for the web. ఎక్కడి నుంచి స్టార్ట్ అవుతుందమ్మా? So as it is a composite section, right? So the web will start from the flange. కింద నుంచే స్టార్ట్ అవుతుంది. So there is a long stirrup which will take care of the shear reinforcement. Okay, shear force. And the shear reinforcement will be provided even in the flanges also. Bottom flange, top flange కూడా provide చేస్తారు. ఎలా? You can see. This is the one. Okay, so ఇలా provide చేస్తారు. Right? And the next one, on top of the flange also you can see the stirrup reinforcement, shear reinforcement. ఇక్కడ చూడండి, U shape లో ఒకటి ఉంది కదా. So this U bar, this U reinforcement, what is the dia of this rod? This rods will be dia of 12, spacing of 200 mm. Why 12 200 అంటే ఏంటంటే 12 is the dia, 200 is spacing. Okay, so towards its length you have to provide shear reinforcement in the flange with a spacing of 200 mm. Okay, అర్థమవుతుందా? అది. సో టాపే కాదు, ఈవెన్ బాటమ్ కూడా మీకు ఒక reinforcement కనిపిస్తుంది లైక్ దిస్, విచ్ విల్ కంబైన్డ్ విత్ ద టాప్ డెక్. ఇప్పుడు ఫ్లేంజ్ పైన కనిపించేది ఏంటి? వాట్ ఈస్ దిస్? దిస్ ఇస్ ద స్లాబ్, బ్రిడ్జ్ డెక్ అన్నమాట. సో ఇది కాంక్రీట్ డెక్, ఇది పిఎస్సి గర్డర్. ఈ రెండింటిని కవర్ చేసే రెయిన్ఫోర్స్మెంటే ఈ రెయిన్ఫోర్స్మెంట్. సో అందుకే దీన్ని షియర్ పీస్ అని కూడా అంటారు. ఓకే, షియర్ రెయిన్ఫోర్స్మెంట్ ఎట్ ద టాప్ ప్లేన్. ఓకే, సో వై? బికాస్ దిస్ షియర్ రెయిన్ఫోర్స్మెంట్ విల్ హ్యావ్ ఏ జాయింట్ బిట్వీన్ డెక్ అండ్ అన్ గర్డర్. గర్డర్ కి డెక్ కి షియర్ లాక్ చేస్తుంది అనమాట రెయిన్ఫోర్స్మెంట్. ఓకే, సో దిస్ ఇస్ ద ఎగ్జాక్ట్ reinforcement diagram for shear for the on the flanges. Okay, right? Sorry, what is this? This is at section 1-1. And if you see the girder from end, it will be in the form of a trapezoidal shape. If you see the girder at section 2-2, what do you mean section 2-2? And ఇక్కడ చూడండి, ఇది longitudinal girder. The girder is having a length of around 27.750 meters, right? And 27.750 meters length low. If you see the girder at this section, it will be in a trapezoidal shape. If you see the same longitudinal girder at this section, it will be an I shape. Okay, at center it is 3-3 and the section 3-3. At center it will looks like this shape. Okay, so atla section అనేది మనకి longitudinal girder లో it will have a different dimensional pattern ఉంటుంది, right? Practical గా మీరు చూసినప్పుడు మీకు అర్థమవుతుంది. Right? So, okay, let's talk about the thing. So, what we are discussing? We are discussing about the transverse reinforcement, nothing but stirrups or shear reinforcement for the flanges. So, why? So, because there will be a shear lag effect in the flanges. So, that is the reason why horizontal reinforcement will be in the form of a shear single leg or closed stirrups is going to be provided in the flanges. Okay. So, the following figure shows the shear stress in the flange at the face of the web. Web యొక్క face దగ్గర you can able to identify or see clearly how the shear lag effect will take place on the surface of the flange. Okay, so surface of the flange వల్ల shear effect వల్ల, so you have to provide the shear reinforcement to take care of the shear lag effect to increase the shear stress in the flanges also. Right? So the horizontal reinforcement is calculated based on shear force in the flange. The relevant quantities for the calculation based on elastic analysis are as follows. What are they? First one, shear flow. What do you mean shear flow? Shear stress into width. Next one, variation of shear stress in the flange, tau F అంటున్నాను. Next, shear force in flanges, which is indicated with the symbol VF. Ultimate vertical shear force, VU. కదా ఇవే కదా ఫార్ములాస్ మనం ఇందాక చూసాం. VU is nothing but ultimate vertical shear force. VF is nothing but shear force in the flanges. Variation of shear stress in the flange is indicated with the symbol tau. Tau always indicates about stress. V always indicates about shear force. Okay. So now let's see how the shear effect will be there on flanges. I section లో flanges మీద ఎలా ఉంటుంది. So the following figure shows the shear flow and the shear forces in an I section, particularly in the flanges. Okay. So with the constant flanges, here I took a uniform section, right? So which is a symmetrical section. This I section is symmetrical about both axes, X and Y. ఇందాక మీరు diagram లో చూసింది is this one second. Is this I section is symmetrical? This is symmetrical about Y axis, but not symmetrical about X axis, isn't it? Okay. So all our I sections అనేవి symmetrical ఉండాల్సిన పని లేదు. So sometimes you may find some I sections which is unsymmetrical to both the axes also. Okay. So in that way, so we are talking about a section which is symmetrical about both the axes. Okay. So this is a section. So here you can see how the shear flow takes place in the flanges and the web. Web లో flanges లో shear అనేది ఏ విధంగా flow అవుతుందో చూడండి. Okay, చూసారు. So this is the shear force. This is the shear flow. Shear flow and shear forces in an I section. Right? So this is how. So if you draw the shear flow diagram, I think you all know how to draw the shear stress diagram. Shear stress diagram for an I section ఎలా ఉంటుందమ్మా? Can anyone? How the diagram will be? The diagram will be something like this. One second, let me show it in a board. Yeah. So let me take an I section. Right. So in this an I section, how the shear stress flow takes shear force or shear stress is an I section along with them. So this is the neutral axis. Okay. I think you all know shear stress will be more where the width of the section is less. కదా ఎక్కడైతే విడ్త్ తక్కువ ఉంటుందో అక్కడ షియర్ స్ట్రెస్ అనేది ఎక్కువ ఉంటుంది. విడ్త్ ఎక్కడైతే ఎక్కువ ఉంటుందో అక్కడ షియర్ స్ట్రెస్ అనేది తక్కువ ఉంటుంది. సో హియర్ మోర్ విత్ జీరో షియర్ స్ట్రెస్, రైట్? At this junction shear stress varies ఎందుకంటే so here there is a sudden decrease in the width of the section. ఇది width కదా. So this is the width of the section. And what is this? So this is small b. So at this joint, what happens? At this joint, there will be a sudden decrease in its width. Decrease అయినప్పుడు ఏమవుతుంది? There is a sudden change in the shear stress. అందుకని మీరు ఇక్కడ చూస్తే this shear stress is for the flange and this shear stress is for the web, right? And the maximum shear stress at point where having less width in the web. Okay. So this is the shear stress diagram. So in the same way, how you can able to draw the shear flow diagram? దీనికి shear flow diagram draw చేయాలంటే ఎలా draw చేస్తారు? So this is the shear flow. Okay. So the shear flow will be change takes place exactly at the Y section. Y section lo change. Okay. So that's what is showing it clearly now. Okay. So this is the shear flow diagram. So the maximum shear flow, shear stress with respect to the flow will be more at Y axis. In that మనం X axis లో maximum shear stress చూసాం. The shear flow also will be more at Y axis. Y neutral axis లో maximum shear flow ఉంటుంది. Okay. So this is how the shear force flow takes place in an I section. Same. Even if you take a T section also, it will be almost same. Okay. So based on this, the stirrups are going to be designed, okay, for the flanges and even for web balls. Right. So the design shear force in a flange is given as follows. Li only Vf is equal to nothing but design shear force for the flanges. So this formula is only for the flanges. Why? Because you all know how to design the shear stress for a web. Okay, అది మనకు తెలుసు. Because tau is equal to F into A into Y bar by I into B. So that formula will shows you how to calculate the shear stress, that is the maximum shear stress of a section. Here we are designing the shear force in a flange. Okay, so by that the formula is Vf is equal to tau F max by 2 into Bf by 2 into capital D. What is Bf? Width of the flange. What is Bf? Depth of the flange. Tau F max into maximum shear stress in the flange. How to get the maximum shear stress in the flange? Flange యొక్క maximum shear stress ఎలా వస్తుంది? So that's what I showed. ఇందాక మీకు వైట్ బోర్డ్ లో చూపించాను కదా. I think it was gone. I think. Yeah, it's there. So in this, where is the maximum shear stress in the flange? This is the maximum shear stress in the flange. Why? Because this is also shear stress, but it is not to the flange, it is for the web. One E value is called. Why? Because at this point your shear stress is 0. So this is the maximum shear stress in the flange, E joint vigor. Okay, this is due to the width of the flange. So E shear stress value మనం consider చేయాలి. Okay, that is what the tau F max. Right? Understand? So this is the maximum shear stress in flange, depth of the flange, width of the flange. So with that you can able to calculate the design shear force in a flange. Okay, so this formula is going to be used. Understand? Right? And how to calculate the maximum shear stress in the flange, which is given by an expression similar to that of the shear stress in the web. ఎలా calculate చేస్తాం? ఆ tau F max అక్కడ మనం లొకేట్ చేసాం కదా. How to calculate the tau F max? You can able to calculate tau F max with this formula. Okay, ఏంటి formula చెప్పండి? What is this formula? This formula we already studied in your strength of material shear stress equation. ఏంటి shear stress equation? Tau is equal to F into A into Y bar by I into B. What is F? Shear force. What is A? Shear area. What is Y bar? Depth from the neutral axis to the center of the shear area. Antena? Center of the shear area, which is subjected to slide, which is subjected to shear off. ఆ పోర్షన్ ఏదైతే షియర్ పోర్షన్ ఉందో ఆ పోర్షన్ యొక్క సెంటర్ నుంచి న్యూట్రల్ యాక్సిస్ డెప్త్ న్యూట్రల్ యాక్సిస్ వరకు. So that is what Y bar. Understand? Bending stress లో Y bar is different. Bending stress to Y bar అంటే ఏంటి? Depth from the neutral axis to the outmost layer. But in shear stress, what is Y bar? Depth from the neutral axis to the center of the shear portion. ఏదైతే మనకి షియర్ అవుతుందో ఆ పోర్షన్ యొక్క సెంటర్ నుంచి న్యూట్రల్ యాక్సిస్ వరకు. దట్ ఈస్ వాట్ Y bar. And what is I? Moment of inertia. Okay. What is the B? B అంటే ఏంటి ఇక్కడ? DF, depth of the flange. Okay, so with this shear stress formula you can able to calculate the tau F max. Right? So none the strength of material set, no new formulas are there over here. Okay, so with this VU you can able to calculate ultimate vertical shear force. I is the moment of inertia of the section. A1 is the area of the half of the flange. Okay, and what is this? Y bar. Okay, ఇది Y bar అమ్మా ఇక్కడ మిస్ అయింది, ఒకసారి చూసుకోండి. Y bar is nothing but distance of the center of half of the flange from the neutral axis